just for you to, I guess, if you're here all along the ride, you can prep to when, I'll say that fateful goodbye. But now, let's talk about this. Methanol is a polar solvent, okay? Is polar, and heptane is non-polar, okay? And which of these two solvents are each of the following solids most likely to be soluble? So what does it mean to be soluble, right? I mean to be polar, right? We actually just discussed this. So methanol, right, has a specific, so meth is CH3OH, so it's going to be like, look like that, okay? So that's methanol, okay? And the way this works is, as we discussed, OH, it's has a polar bond, oxygen and hydrogen, and even oxygen and carbon has a polar bond, which is why exactly this oxygen here is where the negativity is, so that's where it's directed towards. But heptane is just, oops, that's pentane. This is heptane, filled with carbons and hydrogens. Net nothing, because of the fact that the difference between each carbon and each hydrogen is negligible. It's less than 0.4, okay, for your electronegativity. So that's what they mean by this is non-polar. So remember how the whole likes dissolve likes, okay? So we're actually gonna get first these options, and then we're gonna actually draw them out what they look and see if they have a polar or a non-polar side, to be able to see if it actually dissolves in, and it actually gives us the answer right there, really. But KCl, it says ionic. Rubbing alcohol, okay, polar. Gasoline, non-polar. And NaNO3, ionic. So let's start with KCl, ionic, okay? As we mentioned, when a metal and a non-metal bond, okay, the metal is just gonna be like, yeah, take my stuff, okay? And Cl is like, yeah, sure, if you insist. Okay, so now we have a negative and a positive side. And for the OH, we have actually a part of it, methanol. Yeah, methanol. We have actually a part of it that's a little bit more negative, and we have parts of it that are a little bit more positive. So actually, let me just note that. We have parts that are a little bit more positive, meaning that it actually has a polarity. And you know how it goes, opposites attract. So this oxygen will be attracted to that potassium, and the hydrogens and carbons will be attracted to the chlorine, meaning that methanol is good to dissolve in here. Okay, why not heptane? Because of the fact that heptane has no preference. It literally can't even, realistically speaking, connect with any of the KCl. It's hydrophobic. It has no, it's water hating in a sense. It doesn't have any means to actually dissolve in water, and also it means that for any ionic compounds, it won't interact with it. Now, rubbing alcohol, okay? So just to clarify exactly, only methanol can dissolve in the first one, in KCl. For rubbing alcohol, the answer is actually in the name, alcohol. Methanol is a type of alcohol. So now we know, based on that, right, that whatever this alcohol is, it'll have some OH, okay? It'll be like some ROH. So because of that, we know that this is going to be the negative. This is most likely going to be the positive side, and it's going to work like that. Positive side again. Same interactions. Methanol likes that. Methanol actually has a way to attract it to that alcohol. So methanol wants to dissolve here, and heptane says, no thanks, I'm good. Again. Now, gasoline is a complete hydrocarbon. Okay? So, because of that, right, based on that name, it's only composed of hydrogen and carbons. And you notice that heptane is the same thing. So imagine we had a giant vat of heptane only, pretty much. That's the only place heptane would love to dissolve in. But now you come in with something that actually has a polarity, right? There's no way for it to really fit because it's in a non-polar environment. It wouldn't interact properly. It would not dissolve in it. So for this hydrocarbon, actually, only thing that would dissolve in it is heptane. So that's actually that answer there. So now for NaNO3, this one is going to be a shorter explanation because it actually just works exactly like KCl. It even says ionic. So it's going to have that Na side. Okay. And the NO3 minus. And then that polar side is going to go over to the positive. I mean, the polar negative oxygen is going to go over to the sodium. And the positive is going to go over to the nitrate. So with that being said, only methanol, because heptane, once again, says I'm good. So it's going to be methanol, methanol, heptane, methanol for each of these, okay? Let's see what they got. Exactly, they mentioned like dissolves like, which is what we discovered, and which is what we discussed when we said that we want polar to be with polar, okay? And polarity, difference in electronegativities, we definitely mentioned that as well. We in fact used a previous question to help us answer that, and we know that heptane is a non-polar molecule because it's only filled with non-polar bonds, okay? And methanol is a polar molecule, okay? They mentioned the trend of electronegativity, which is what we saw here, okay? And let's see what else they mentioned. Ionic compounds are polar because exactly they have the positive that's given away the electron completely, and the negative which accepted it completely. So with that being said, as I said, soluble in methanol, gasoline, soluble in heptane, and NaNO3, soluble in methanol, okay? And the cool thing is actually is that everything this list is soluble in methanol would also be soluble in water, because of the fact that water is also polar. So this is a nice tidbit, and exactly you've seen when you try to actually mix oil and water, just doesn't happen. That's what's happening with gasoline and such, because exactly oils and those things are typically mostly filled with just hydrocarbons, so they have not really any of a polar side, which is why they don't mix together. Non-polar and polar solvents don't mix. So yeah. So now let's move on to question 28.